Guys, so recording has started, and let us start with the NAT gateways. I'll just yeah. So there's the NAT gateway, and what is NAT gateway? We're going to talk about that. I was going to create a diagram for that. So NAT gateway is that if you have two subnets, and so suppose there's one VPC, and so we're first talking about AWS NAT gateway, and there we're talking about VPC. So in VPC 10.0.0.0/16, and we have one subnet and the other subnet. So here we the subnet, and that is 10.0.0.0/24, and then so that's public subnet. So once I create that, then I'll just show that what is NAT gateway. NAT basically is network address translation, which provides internet connection to the machines that have private IPs. So let me just create the structure here, and private subnet. So suppose you have one public subnet and one private subnet. We have gone through this before as well in terms of creating the environment. So here, this public subnet will have obviously the public VM, and this is going to be private VM. A private VM cannot have internet connection. What labs we have done till now lets us connect from so first we connect to the public VM, and then we connect to the private VM. But that's all. We can install anything if we copy anything here, but this machine does not have internet connection, right? So no internet. No internet, right? So if we go for if we want to connect to the internet from private VM, so it has private IP. Obviously, it cannot have internet. Only public IP based virtual machines can have internet. So how do we, arrange that internet for the virtual machines inside the private subnet? So that's the purpose. You're behind you're behind the NAT protocol, and what NAT does is that it translates public IP. It translates from or it provides internet from one public IP. Let me make it even more simple. It provides internet from one public IP or whatever number you want to thousands of private address, right? But so this is what we are using pretty much every day here in our homes. So we have a DSL router provided by our ISP, Bell or Rogers or whichever, and we are given just one public IP that changes every 2-3 days or every 2-3 hours as well. We get one public IP from our DSL router at home, and that one public IP through NAT gateway or NAT protocol provides internet to all the private IP addresses. Now, the benefit of that is that no one can connect directly to those machines from the internet, but still these machines will have internet connection. A difference between public IP-based virtual machine and private IP-based virtual machine. That public IP-based virtual machine have public IP, which means and public IP is routable on the internet. So anyone from the internet can try to, at least from anywhere on the planet Earth, try to directly connect to that machine if public IP is known, and then the hackers are also specialists and if you want, they have proper tools, then they can hack. But this machine is having only private IP address. So it's not even on the internet. Suppose somebody gives the private IP of this particular machine to some hacker on the internet somewhere in some other country. Obviously, it's a private IP, so it's not routable over the internet. So hacker cannot even try to attempt to connect. So the thing is that with private IP, the machine is not on the internet accessible, but it can have internet for itself with the help of the NAT gateway. So that's the benefit. We are also, our all devices are not on internet, but we have internet connection in our devices. So that's a big security um, you protection, that all private IP-based virtual machines are behind NAT and not accessible directly from internet. They do have internet. They can access internet, but no one from internet can access them. So
So
that would be the main thing.
the NAT gateway is installed on public VM?
Yes. No, public subnet. So NAT gateway gets installed in public subnet, and it's routing because it has to receive internet from somewhere. Internet is in public subnet, and how it is in public subnet? It is in with the internet gateway. It is as we always create internet gateway here for public subnet. So that internet gateway is providing internet to the public subnet. From there, NAT gateway is also getting that internet, and then it's providing it to the virtual machines in the private subnet.
So it's on subnet level, internet gateway and
Yes.
NAT gateway.
Yes.
We
Okay.
will access from
Mhm.
our laptop to
Oh,
VM1.
yes. So if suppose we want to access that virtual machine, obviously we
Okay.
have to go to the public VM, and from there we need to hop to the private VM as we always do.
Yeah.
But if suppose we are there and now we need to download suppose some software from internet, so internet will not be available there unless there is a NAT gateway also available. So you can access through 3389 port. If there's no internet, then yeah, there's no way you can open any website here or install anything here, or download anything here.
So
So
if you want to update anything, like update
yeah,
the
patching.
patching,
So
yeah.
so yeah, that's the thing, that you must provide internet connection to the machine, and that's only possible with that gateway. If this machine has a private IP, the only way to give it internet is that gateway.
Mm. So likewise, you access once you access there, then you make a access from VM1 to VM2, and then you
Yeah.
update.
So accessing is only possible from VM1 to VM2, public
Okay,
VM to private VM, but internet is only possible to the private VM if there is NAT gateway
yes, there is NAT
connected to
gateway.
it. Okay, so here, once we have all this, so then we can always check that if there is a NAT gateway or not. Like there's our end game is there internet here or not while this machine is a private VM. Okay. So what we're gonna do for this, we're going to then just simply create the environment, and we're then going to try to uh, create a NAT gateway, and connect the NAT gateway to the private subnet. So if it is on the private subnet, then private subnet has a DHCP. DHCP is given an IP. So that or internet will be provided within the whole private subnet to any number of virtual machines that are available. ONK. So I'm gonna just put it in the slide as well, and let's just get going.
So we can have five subnets in one VPC, right?
We can have maximum 200 subnets in one VPC.
Oh, okay, 200 subnets in one VPC and
Yep.
five VPC We can create 5 VPC, right?
Per subscription regions. One region per subscription, 5 APCs. Yeah. So it's only happening with my AWS labs that I have to practice more. If they have changed anything, then I have to troubleshoot. That really is, bad. In my Microsoft labs, nothing, no such thing is happening. Very, very few areas where I had to troubleshoot. So AWS I've touched after a bit longer time than Microsoft, so that's why the already created labs that were supposed to be simple, straightforward are not well. They used to work, and yeah. So I'm just going to go ahead and let's go ahead with that. So that is network address translation, and so it provides, yeah, what we have talked about there. I'm just gonna put that diagram here, and let's create that environment. Internet to private IP based VMs via one.
Okay, can you also write down like on the inbound rules where we apply inbound rules and outbound rules? What we say
So inbound is access only available, but
inbound
it's
access
just the
here.
outbound. It's just the outbound. Well, internet is available, so obviously the traffic, outbound traffic will be so inbound, outbound both. Suppose you're downloading something, suppose you're sending an email from machine to outside, because now you have internet. So both inbound, outbound traffic is connected to internet, right? Internet is available. This means both sides of traffic are available. There's no one specific side that is.
In this condition, there is no specific
Like
no
uh,
restriction on inbound or outbound.
uh, the no restriction, inbound outbound restriction we can create ourselves. This has nothing to do. We are just providing internet connection, just like you're providing water to a apartment. So it's just we're just providing internet to this machine. So about inbound, outbound, obviously we need to create our SGs, security gateways, right?
Yes, yeah.
So those SGs will, and this is manual. So which ports you want to open, which ports you don't want to open. So that is obviously we have to create. Otherwise, it's not gonna be a complete lab.
So in real environment, what we do, we allow both inbound and outbound on a. We could
Outbound
apply
is
inbound. Outbound is only available. Uh, Inbound is only allowed from public VM1. Outbound is should be off VM2.
so outbound is always allowed. Outbound is always open. All traffic is open in every machine. So it's inbound that we need to worry about. So from inside to outside virtual machine, any traffic could go. It's already open all the time. Unless you want to close it, yes, it's up to you. Right? But when there's an inbound traffic, that's where the threat is. So then you have to control that what
Yes.
inbound traffic should come and what should not.
And there is a condition on this for inbound.
So yeah, what we're gonna do is we're gonna do the same exact same lab, and that is 3389 port. We're gonna enable that on our machines. But here, yes, when the inbound traffic or outbound traffic is opening, so we can open port 80 as well as port 443 traffic. We can enable that when we enable internet there, and also 3389 because it needs to. We will still need to connect to it in order to check that internet is there or not. So three type of traffic will be open here. This machine, while 3389 only open here because we need to connect from outside to this machine.
443 is SSH and port 80 is
SSL. No, so
SSL.
it's HTTPS. It's HTTPS.
43
And
and
port
yeah,
80 is
HTTP,
HTTP. HTTPS and
and this
HTTP.
is HTTP
And this is RDP.
RTP.
Okay.
Why we need
So
RTP open here?
because we need to access it. Why we
Oh,
need to access? Because we need to check if the internet is provided here or not. Internet is working here or not.
port 389 should be open in VM1.
Both VMs it should be open.
So both VMs. Okay.
Are we accessing VM2 from VM1? I mean,
Yeah,
okay.
we need access from VM2 to VM1. Once we are inside, because we cannot directly access VM1 because it
Yeah, because
has
it's private, yeah.
private IP. So we have to go from here to here. Then we need to check if the NAT gateway provided internet or not.
We add here load balancing also. As much we, you know, rules we can add here. This tab.
We can add here many things, many things.
Yeah,
But
add 4 or 5 things. So it could be our like
yeah,
load balancing and what were
yeah.
auto
So
scaling.
Raza Sahab is very demanding, and he wants, you know, very big labs. So yeah, I have to do it, right? So
A small,
I have to plan
make
it.
a small lab. Add 4 or 5 features.
Understand what you're saying, but right now it's a NAT gateway lab that I prepared because I have to first prepare and mentally be ready for the whole lab, and I have to practice everything, right? So when we add lots of things to the picture, obviously I have to first practice all that, and then if there is any error, then I will have to troubleshoot. Even after practice, there's something that comes up. So there's so many steps there, right? I understand what you're saying. Yeah, it's gonna be fun, everything is there. But yeah, I have to prepare that, so I need time for that, and that's the thing that I really am
Or
lacking.
we can add here uh, high availability.
Resume now, and okay, so what we were doing was that we're going to be creating the whole environment, and I've added some more drawing here, so I'll just copy this um, to here and remove this. Let's go ahead. This is the full diagram. Okay, now let's. I'm gonna start building it, and this is just specific way we always did it. So if you have been following the labs, if you've been doing the labs, then it should be easy to understand. So I'll just create the whole environment step by step. Okay, so here I'll go for VPC. Here I have one VPC actually already created from last time, and I need to still troubleshoot. This network interface is stuck, but yeah, after the class I'll try to do this. Now I'll just go for create VPC here, VPC only. So I'll just go for honor dash VPC dash 29 April 23 um, and dot 0.0.0/16 and okay. So once we create that, I'll just follow up with the lab. Yeah, this is done. I'll create two subnets quickly, public subnet, private subnet. We did that before. So I'll go for subnet. So there's um, as the VPC. Okay, it's still gateway. It's in April. So see. So I'll just create subnet one, and which VPC? It is the 29 April one, and it's armor dash subnet dash public. And that is also 29 April 2023. I'll top control C name. Just for organization purpose, I'll put it on US East 1A and 10.0.0.0, so it's /24. And yeah, so public subnet is there. And once it is created, then I will enable it to distribute public IPs. So it's created. I'll just select that and go for edit subnet settings and enable auto assign public IPv4. This means that please allow virtual machines inside to have public IP address to get internet connection. Okay, so I'll click save here. Now it has internet connection enabled. So then I'll go for subnet and 299 April. So it was named subnet 29 April. Yeah, organization purpose 1A, and this
Should be
is
one B. Subnet
uh,
should be one B, right?
not should be, but whichever subnet we want, we can connect this subnet to. But this is for organization. No, this is not a high availability kind of thing going on. So this is just for organization purpose. And yeah, if we want to have some services attached to it that are subnet specific, then we'll be stuck. That's why it's
So
1A.
for the best practice, it should be in a different subnet.
Well, this is no, it's not best practice according to the scenario, right? If you're doing load balancing, yes, it's the best practice. When you're suppose you want to connect something, some virtual disk or something. So when you're creating a virtual machine, so then it has to be the same subnet. But right now, just do it. Okay. But if the lab, whatever I test, I try to do that. But this is not best practice. You're mixing some other scenario with this. But anyway, I'll just do it, and hopefully it's not going to. I understand that it's not going to be any bother, so that's why I'll just go for it. But yeah, it's not compulsory to do it, right? And in this scenario, no, it's not as a best practice. So, subnet. I'll just filter that. So enter. There are 3 subnets here. One older one that I don't need. No, that one network interface connected to something. I'll be troubleshooting that later. Anyway, these are the 2 subnets here. I'll just go for the private subnet as well. What I'm checking here is edit subnet, and I'm not going to enable the public IPv4 address, so I'll keep it as is, so nothing to change here. Now, if we go back to this diagram, so this has internet connection, this does not have internet connection. I'm going to quickly create EC2 instance for public subnet that will have 3389 port open. I will then create a private EC2 instance with 3 ports open, and it's accepting traffic only from here. So that we can connect from here, but also NAT gateway should be coming from here as well. So if it accepting traffic from this subnet, so NAT gateway be also here. I'll go back here and okay, here, so instances. Your first name, on PC to public, and here it's Windows guy background, right? Otherwise, it's just pinging and everything. So, T2 micro, key pair, create new key pair, key pair 29, 3, key pair, and edit network settings. So, it's not the default VPC I want this created in. It's the today's VPC and auto-sign IP. Auto-sign public IP actually enables creating a public one. So I connected with private subnet, that's one. It detected private subnet by default, so I changed it to public subnet. Now the auto-sign IP is okay. And security group would be having some ports. So select existing, create new. So this is dash like dash okay. And control C 20. Need to create add some more rules here. First is yes 3389. So I'll be connected here. Second is um, add again, and this would be port 80 to check, and the traffic would be coming from the other subnet, which is standard 0.0.0 slash 4. So playing traffic coming from the subnet, and then add security group pool here. So 443. This is also expecting traffic from its subnet, and well, then this also expects traffic from public subnet. Actually, it's saying anywhere. Oh, guys, this is not that subnet. This is public subnet. So if we go to the diagram, public subnet is getting traffic from internet. 3389 is the only other traffic. Is the only traffic that we are supposed to enable. This is just like so. I was adding other ports there, but those will be not issue for us because it will have internet already. It has public IP. It will have internet already. It's for the private subnet and private EC2 that we need to add extra ports. Okay, so public subnet, enable, create security group, and 3389 is there. That's all we need. Disk is there. That's it. So yeah,
So we need only 3389 open here, right?
yes.
Security group.
And one more thing is that delete on termination. Okay, that's it. And I'll launch instance. One instance is created and is public. It's to private. I'm just going to create that now. So this public instance is created here. I'll go for launch instance again. And Microsoft, we know the drill now. T2 micro. I'll go for today's key pair 29 April. And yeah, now we need to be careful. So here subnet is also first the default VPC. No, it's our VPC, and but took the private subnet, which is okay. No auto assign public IP, okay. And so here, yeah, that's where we need to put comments. So not here. Private SG. Yeah, first is RDP in the private subnet. So if I go to the diagram, and then we need 443 and 80 as well. Although just 80 is also okay. It just opens websites. So um, so I'll just go for add security group rule and T. Also, where is it accepting traffic from? RDP traffic, where is it private subnet accepting from? So it is from just the other subnet. And port 80 traffic, it's also accepting from other subnet. Like if I just yeah, okay, let's do it. And then four and 443. Okay, traffic coming from public subnet. So port 80, port 443, and 3389 in the private subnet. Also terminate, delete on termination. Yes. Okay, if I go up, so SG is done. VPC is selected, correct subnet is selected, correct pair and T2 micro and Windows and private. Yeah, okay. Good. Launch instance. Okay. So once this is done, so the machine is getting created, and I'm just going to quickly connect to the public VM. So RDP client, download more desktop. Password, we know the drill. Upload private key. This is the private key in my downloads folder in my laptop. Encrypt and get the password in OneNote. So this is the public VM, so the public IP is there, and obviously the administrator is the username. Okay, so I'll just this is password. Let's get going. Downloads. I'll connect to the public VM, put the password there. Three treatment port was open. Okay. My internet gateway for this. Okay. So I'll go for this is public VM, but it did not connect. So if I go to internet gateways, I do not touch that. Yeah. So that, oh yeah, obviously. So one thing obviously is this dude here needs to be connected. So I need to create an internet gateway and create a route table as per our exercise, and then tell the route table, hey, you're one side you're connected to the internet gateway, other side you're connected to the public subnet. Okay, so I'll go for internet gateway here and create internet gateway. Internet gateway. Um, Once internet gateway is created, so the internet gateway this guy has to be attached to VPC, and then route table needs to be created. So this guy needs to be attached to VPC, so I'll click the button attached to a VPC, and there are two VPCs appearing here. 29 after all is the one. I'll click attach internet gateway. Then I will go for the subnets and actually route table. I'll go for the route table, and I'll create a route table there because according to the diagram, I need to tell this route table, hey, from this internet gateway, this subnet, we need to connect the internet. So I'll go for route table, dash route table, dash 3, which VPC is part of. It's part of the VPC that we create today. And then once the route table is created, I'll select that and tell that, hey, you have actually a internet gateway, and then you need to connect to a public subnet in that VPC which we connected to. So routes, go there, edit routes, and add a route here. So it's all the traffic from internet expected to internet gateway. There's only one that we have, and save changes. And we will be going to the subnet association. So internet gateway is created here. Route table has been told that you're connected to the internet gateway. Now route table has to be told which subnet to connect this traffic coming from the route. So I'll go for add subnet associations, and the public subnet is where the internet gateway should be sending the traffic to. Now when I try to connect, it should be connecting because now from internet gateway to route table, it has provided this subnet. Okay, so I need to check that.
Route table has to define like you are connected with the internet gateway, and
Yes.
what is the second thing?
Route table has to define that you're connected to the internet gateway, and then so here, and then it has to also be told that you need to connect to which subnet. So
So
I'll
it means public subnet.
yeah, this subnet, public subnet. Yeah. So I'll connect and then go for that is not my IP. That is the IP that I copied here. Password. Did I say IP? So that is not the word that I knew. Oh, it's okay. Yes. So the machine is connecting now, which is means that we have made the initial connection. And so yeah, from here, internet gateway to the machine, we are connected. Now we need to connect to the private VM and check if there's internet or not. Obviously, there shouldn't be any internet connection here. So I'm going to make that connection to the private VM now with MSTSC. So I need to know the IP of the private VM and the username password of the private VM. Make a connection from public VM to private VM. And there shouldn't be an internet connection because we didn't create a NAT gate when connected to this subnet. So I'll go back and I need to know the EC2, the information of the other EC2, EC2 private. So IP of the private VM is this. Obviously, username is administrator, but I'll try to connect and get the password for that. So RDP IP is this. Yeah, I just need to get the password. It's the same key pair that I used for the first machine, and obviously the username is always the same for Windows. So administrator. Now I need to make a connection from within the public VM to the private VM because subnet is only accepting traffic from its subnet. So I'll go to the VM and just initiate that connection, remote desktop connection. So it's supposed to be working. I'll go there, and there's a remote desktop window that I to open. So MSTSC Microsoft Terminal Services Console. So when you type that, so remote desktop connection, or just simply type remote here and it will connect it. Open that again. So remote desktop connection, it is asking for an IP, which is this 10.0.156. Right. Okay, that's good. It is asking for username password. This means the connection was made. And the password is here. Okay, so it's making that connection. So I'll make the first machine window smaller.
Is VM1 and VM2 connected to the same subnet?
So we are connected now to the first VM, and from inside the first public VM, we are now making a connection to the private VM. Within this VM, we're making connection to this VM.
So the public VM, does it have any private IP as well, or just only
Oh
public?
yes. So if you see that, always it's going to be
0.0. Okay, I've seen it.
yeah,
237.
private IP and public IP.
Okay.
And yeah, so because there is routing between the two tables.
On the route table, right?
Yeah, route table. So here, route table is there. Yeah, so route table enables routing, and that route table is connected to both subnets. So this route table actually ends with 5578. Go to subnets. So these two subnets. So if I go for uh, these two subnets, 29 April subnets, are supposed to be connected to the same route table. Well, actually, route table is here 5578. This is the subnet. This is which one? Public subnet is not to the 5578. Private subnet is connected to another route table, but there is routing in by default. Routing is enabled between the two subnets. Suppose I create 50 subnets, so routing will be automatically enabled between all those subnets there. This routing table, if I go to the routing table, it has associated. Yes, we um, created. Oh yeah, this route table is not the default one. I created that, right? And I associated it with just one subnet, but the default route table that the subnets, both subnets are supposed to be connected to, is different. Let me just show that. So these two are the subnets because that these two are supposed to be showing the same route table because I also associated the public subnet to another route table, so that's why it's showing different. Otherwise, they still have routing enabled, which means that they are also connected to each other while I connected the public subnet to the internet gateway. So if I go to the diagram, yes, there are two route tables. Basically, one route table gets created by default. That is when, as soon as you create two subnets in Microsoft Azure as well as in AWS, the route table, default route table always gets created
So you created only one route table
here. Yes.
associated with the public subnet.
So this is just connect internet gateway to the public subnet. That's why I had to create another route table. Otherwise, by default, one route table always automatically gets created. All right. Well, I'm gonna check that. So I'm connected to the private instance now, which is another instance inside the public instance, right? In the public instance, if I open the browser, I should have internet because it has public IP. Public IP is always routable, accessible from internet. So one day on Sunday, when it opens this. Oh yeah, now the Internet Explorer is opening. Okay, I'll make this window bigger. So I opened Internet Explorer in the public subnet, the public machine. So obviously there should be internet connection. There is internet connection here, and if we go for the private subnet, a private virtual machine, so it should not have internet connection. So I'm still in the public, virtual machine. Yep, it has internet connection. So where is the private one? From inside the public machine, we connect it to the private one. So this is the private one, and so here I will go down and I will open the browser. It will be quite embarrassing if it had internet connection, this machine. So then we'll have to figure out why, but it should not have connection. Wow, it's too slow. Here. I've opened the browser within the private VM as well, and I'm expecting that it should not have any internet connection. This is the public VM browser. This will be the private VM browser. Wow. Team is, oh yeah, it's t2.micro. Oh, serious? Okay, now it accepted the click. It's not too slow, it's three slow.
This shouldn't be supposed to get internet, right?
So I'm opening browser to check if it is getting internet or not. It's not supposed to.
If we do subnet association, then I think it could be open.
Yes. If we, well, subnet association with happens with a route table and depends on uh, which route table you're associating it. Yes. With that route table which I created, if I associate this one as well, yes, then it should have internet connection directly from the internet gateway. But we haven't done that before, and this is not recommended as well. I uh, opened that other machine. So this is that machine. So this is that machine, a private machine, and there are some initial stuff here. Start without your data and confirm and start browsing. Okay, so CNN.com. We can also, while this website is deciding to open, we can also start sending a ping to. If I go for CNN here, oh man, it's too slow. Click here and okay. Okay, it's just moving step by step. With CNN, this is the machine where internet should be there. And this is a public machine. I put CNN here and I put CNN there, right? Both places. Now I'm just trying to go up. I put CNN in the private VM. So in public VM, it's opening. Um, and here it's still thinking, but oh, there you go. So it does not have internet connection, can't reach. Obviously, it's private VM, so it cannot reach. Here, public VM, it reaches. We're good, right? As far as the result is that where internet should be and where internet should not be. Now we need to uh, make sure that we provide internet connection to this machine with the help of NAT gateway. Uh, man. Okay, so news. Maybe I could just put some other thing for bad news. Okay, so now what to do? We need to have NAT gateway. So where is NAT gateway? I'm going to go to the NAT gateway in AWS console. I'll create that NAT gateway, right? And I'm going to attach it to the public subnet because it needs internet connection from there. And I'm going to assign it one more thing. What is that? I'm going to assign it an elastic IP. NAT gateway needs to connect to public subnet. So make it NAT gateway needs to be assigned an elastic IP. So two things that needs to be that are required by NAT gateway. So it will be on this side. And third thing is obviously NAT gateway needs to be told, hey, who to provide internet later. It needs the internet itself. So I'm going to create it and I'm going to tell it, hey, you're connecting to the public subnet, and hey, I'm assigning you a elastic IP as well, public IP. And then we will tell that you are supposed to connect to the route table here and provide internet to this private subnet that does not have any internet connection right now. Okay. So first step is this, create one. Second step is tell the route table that I'm providing internet connection to the private subnet. That's the next step. So first step, where is NAT gateway? And we're going to create that. I'm in VPC management console, VPC dashboard, and NAT gateway is this. And then I'll go for create NAT gateway. Which subnet is it going to be attached to? And that's going to be the public subnet. And where is the public subnet here? So there's public subnet 29 April. There's a private subnet 29 April. I'll go for public subnet. And yeah, select the connectivity type for the NAT gateway public. So then there is also one more thing is elastic IP. An elastic IP address to the NAT gateway. So did we separately purchase the elastic IP? We know that we can go to the VPC or instance EC2 management and then create a new elastic IP, or we're just saying yes, instead of we going there and creating an elastic IP, why don't you just assign elastic IP for us? So I'm just going to click allocate. And then that's it. So we can create a NAT gateway. So once that NAT gateway, like it is pending right now, I'm gonna go to NAT gateway. It takes time, and then
You,
once we have given, yeah,
you can assign now route table in
yeah.
the meantime.
Once it is created, it's pending right now. So refresh, still pending. Yeah, it takes time. Route table. Hmm. All right. So I'll just refresh that again. it's still pending. It's a huge gateway, I guess. So gonna go to the route table with the private subnet now, but obviously when we are assigning the route, the NAT gateway should be available at that time. Oh, there you go. So now I'm going to go to the subnets here. So the idea, as we talked about this, was that it needs to be told with the from the route table. Through the route table, it needs to suppose to give internet connection to the private subnet. So I'm just going to go back here and go to the subnet route table. Sorry, and once we go to the route table, we will be checking which route. So first I'm going to check the subnet because it has to be the route table of the private subnet, which is route table. So I'll just go down. I'll just uncheck the public one. Only interested in the private subnet. There's a route table here, the private subnet, which was highlighted. And this route table, once we are inside the route table, the private subnet, there is a route that is showing here, and where is it getting the traffic from? That needs to be shown as well. So if I go to the routes, so I'm going to click Edit Routes and add route. Remember that this is the same way we created Internet Gateway route. So this is getting all traffic or any traffic from who? From NAT Gateway. So the route table that is connected to the private subnet, it's now being told, hey, you have a new route. Hey, private subnet, you'll be getting internet traffic from the NAT gateway, and that will be any traffic, like all internet traffic. So I'm just gonna save that, right? And it's gonna take some time as well, a little time. So if I go back to the route table, that is kind of it. And
Can you add a subnet association also to the private table?
no, it's the route table is already connected to the private subnet. So if I go there, first I go to the subnet, and then I say that, okay, where's the private subnet? So that's the private subnet, and private subnet's route table is this. So I clicked it. Obviously, it's connected to the private subnet already. So see this subnets with a association. So it is connected to private subnet only already. So if it's already connected, we cannot associate the same thing again. Okay, so once this is provided,
It is already connected with private subnet.
yes, exactly.
Oh, okay. So we cannot do double.
We cannot do double. That's the thing. Okay, so if we go inside, well, it may take time. It may just start working right away. But we know that if we go to here and go for there was a website called Tech Republic. It used to be a site. It still exists, but I'll just put some site name there. Oh, it's too slow, but anyway, I'll just okay. I just dragged it here, but it's in shock. T2 micro, yeah, in T2 micro we have like Windows 2022, which is these problem. Okay, so right, breaking news. Now we got internet here as well. Well, we already had internet here. So the gateway, so CNN is opening now here. It was not opening before. If I go to the, so yeah, we introduced the NAT gateway. First we checked without NAT gateway and there was nothing opening there. And we created NAT gateway. We connected it to the public subnet. We gave it an elastic IP. Then we attached it to, did a route to the route table. And we told this route table, hey, you're going to open a route from NAT gateway to the private subnet. Because we went to the route table which was connected to the private subnet. We told that route table, you're going to have another route, but this is coming from a NAT gateway. Yes, if it's connected to NAT gateway, yes, all private IPs will have interconnection while they are still private. You cannot connect from outside there, this one, but now it has internet connection as well. And only those can connect who are allowed to connect and from which IPs they are allowed to connect. It has also internet connection. So if I go back to this, it has internet connection here. Just too terribly slow. Otherwise, it's working fine. So that's our Czech
So
Republic
we
I put there.
created a NAT gateway first,
Yes,
and then associate and then tell the router and
Mhm.
tell the route table. So we have a NAT gateway
Yes, here
which is
and
associated with the private one
exactly.
and with the elastic IP because it needs an IP.
Yeah, NAT gateway needs a elastic IP. So yeah, so that's the NAT gateway, and it's working fine. I think this diagram is not complete, so this is the complete one. Make it a bigger one. So that is NAT gateway, but there are many other things actually. I need to create a transit gateway lab as well. I'll be creating that. It's not a big lab. I just need to confirm everything because it's going to be a bit bigger environment. We'll be creating 3 VPCs and connecting them one by one, and then we'll talk about VPC peering versus transit gateway, and then we're going to do a lab on transit gateway as well. But till then, obviously, then I'll be including that lab in next week's lab class. But we have to go through some of the other options as well. Wherever the labs are required, obviously, I will keep on adding those labs here because many of the labs here we have done and understood some of the options there as well. There are so many new features that have been added here, and I want to properly, I want to include a lab. Otherwise, we could have gone for theory and transit gateway theory, and this is that. But without lab, obviously, is no fun. So, and I'm taking my time. Obviously, I'm not in a hurry to finish the course, but the labs should be there, right? And we need to understand properly. So we will be covering many of the topics here. So right now where we are is we have talked about rule groups, domain lists, firewalls in last class. You can just go for all the for the whole video of the last class. to cover that. We also talked about ACLs and security group there. We have covered the virtual private network as well, VPN. But here, verified access instances, this is the area, and it says new here. Normally, whenever they add, it's if we have gone through many of the topics here, then the new topics also do make sense right away. Like enables customers to provide secure VPN-less access to their corporate applications. How can you have VPN-less access to corporate infrastructure? Users can securely access applications from anywhere. AWS verified access, VPN-less access to corporate applications. Connect to trusted providers. Use your existing corporate identity and device management service. Express access policies. So there are some. This concept was introduced by Microsoft as well. Always Connect was their service where your laptop, as soon as you open your laptop and as soon as you connect actually to the internet in your laptop, so you're automatically in the background get connected or connected to your office environment. That is called Always Connect in Microsoft. So it is AWS says that, hey, continuous verification. So access if your laptop, whenever you open and it has internet connection, as soon as it has internet connection, it connects directly to your office. So this means your laptop is always connected to your office whenever you power it on, right? And have internet connection. So this means that policies can be deployed there to your laptop or devices, and authentication can be confirmed continuously, and log files could be accessed. Obviously, this all requires then you have continuous communication. But that was the service there by Microsoft. AWS Verified Access makes it easier to enable secure access for corporate applications without requiring a VPN. So built using AWS Zero Trust principles, AWS Verified Access continuously validates each and every application request in real time before granting access. So if we go more in detail here, you can provide secure access to your applications without requiring the use of a VPN. Verified access evaluates each application request and helps ensure that users can access each application. So benefits, again, if you have an application, guys, it's going to continuously try to verify each connection. So suppose you have here, you have an application, because first of all, it shows here, you can also notice here, return to console, and
It is not a security breach, could be like.
so it makes sure the authentication is there. It makes sure that the access with whoever connects, whatever next connection is there, is coming from the legit source and not some hacker. So there is that create verified access instance. So if I click that, create verified access, a verified access instance is a regional AWS entity that evaluates application requests and grants access only when your security requirements are met. So there will be an instance that you will be connecting to. So yeah, that's what the map I was just trying to create. In fact, let me just create a new one. So you're having this AWS or application. So AWS, you have applications here, and these applications need to be connected by maybe hundreds or thousands of users all the time. But you're trying to check that, hey, where are they connecting from? Maybe from EU, maybe from Asia, maybe from South America, right? So not US, America. So the thing is that people are connecting from all around. Are they actually legit users who are connecting? And it's not like once it's verified, So suppose the user got connected, and first time it was verified that okay, who are you? What's your password? Where are you coming? This is the IP range you're coming from. Yes, this IP range is added here. Okay, allowed to enter. Then the connection got disconnected. At once the user wanted to connect, it remembers some of the information. It lets the user connect again. So what verified access is that whenever it disconnects and creates a new, again attempts to reconnect, so initial investigation starts again, and the user is again checked with, hey, which IP you're connected to, and packet level inspection is going on, and what ports you're allowed to connect to. So whenever there's a new connection, there will be initial longer investigation will happen. This means that whoever makes a connection will be always a verified connection. And again, if the same user connects and disconnects, suppose there's an internet connection issue. It could be that the hacker disconnects somebody else's, a legit user's connection here. A hacker tries to disconnect that, and have some technology that it connects pretending to be this user. So that is possible, and it just investigates every time. Suppose there's a connection disconnection within 2 seconds. So it will start initial investigation again to checking that, oh, okay, so again, where are you coming from? What is your session ID? Are you aligned with this IP source or not? Those are the things that. Now, they're saying that if you want this verified access to happen, so here in between your application and this, so there will be an instance. Oh, that's a big one. EC2 instance so the traffic has to go through this, and the verification software will be inside. That will say, oh, whoa, where are you going? Okay, come here and let me check you. And every time you're connecting, I'll be checking you with the verified, software installed in this instance. And after that, you will be connecting to the applications that I have here in the background. So that's what create verified access instance. And a verified access instance is a regional AWS entity that evaluates application requests and grants access only when your security requirements are met. Right. So if I click that info as well, you have the option to attach a previously configured trust provider during creation of the verified access instance. You can also create the verified access instance without a trust provider and attach one in the future. So trust provider is that like there is Azure Active Directory, or if you've heard about that. So Azure Active Directory, it goes for authentication, it checks authentication, it checks authorization, it does auditing, all three things. So whichever trust provider you have to attach it to the instance, and it will then keep on verifying access. Suppose you have some other security software you want to connect, then it says that you can provide it at that time. So verified, there's a instance name it's asking, description asking, but it also is asking for verified access trust provider. So create a verified access trust provider. There is create as well. If I click the create verified access trust provider, so integrate with supported identity or device state management services. So device state management services. What is the state of the device? Obviously, you have to have, you can see here IAM, identity and access management. So you have some kind of trust provider that does use trust provider type, either IAM, identity center, identity and access management, which means identity is authentication, right? Identify. Access, identity and access management. Access is authorization. So authentication, authorization, management, or merging these two services. So either you want to go for that, or you want to go for OID, OpenID Connect. Maybe you have some other website where you want to connect, where there's a maybe some kind of IAM service that checks authentication, username, password, checks authorization, which is permissions, and then lets the users act only. So do you have some kind of IAM that you want to provide? The identifier to be used when working with policy rules. So it has to be all prepared that where is your Active Directory or where is your identity provider. So once you have purchased that service, only then you will be able to create that instance. If I go back here, verified access. So there's that list that you can create here for verified trust providers, access trust providers. This is the list. And again, did you purchase or enable in IAM Identity Center console, IAM Identity Center? So it says that, hey, do you want our own AWS provided IAM Identity Center connected to this EC2 instance? So where's this one? So do you want IAM of AWS or some other? Remember that we installed Active Directories as well, Microsoft Active Directory. So do you have another one? It's going to be like $180 per month or like that. But whatever identity access provider you want to connect to this EC2 instance, so all connections will be checked and authenticated and authorized before they reach the applications. Okay? So that's what it is about. If I go for enable an IAM identity provider identity center, so then that's another service that you have to purchase. That's a third service. It just says that create a list of your trusted IAM identity providers by adding them in the identity center. So it keeps on going ahead. But the benefits of IAM Identity Center makes it easy to connect an existing directory, like Active Directory or any other directory, or use the built-in Identity Center directory to manage user access to AWS accounts and cloud applications. So if you enable this, then it will use AWS provided Identity Center. Remember that this IAM, if I click that IAM, we had gone through that, all the features of that. So we created a user there, we created a group there, we created policies there, roles there. So do you want authentication and authorization to be managed by AWS's own IAM or Identity Access Management or not? So if you want that, then you have to enable that. I am already, it costed me $189 already because two environments I forgot to delete. But we need to just understand that, okay, you have to have an identity center available. And then once you have that identity center available, you can attach it to this instance here. If I go here, this is the instance, create verified access instance. So verified access is all about you want to attach an IAM, identity and access management, to an instance and let all the traffic hit this instance, go through the authentication and authorization. Obviously, developers will be involved there, programmers will be involved there, and then ultimately connect to the applications that you have. And it's going to be more thorough investigation of who is connecting in real time and how long that person is connecting, where it is connecting from. So it's going to do all that. So this is overall what is verified access. Obviously, we don't have corporate applications, big applications to connect to, and developers would be involved in connecting this verified instance to their developed applications. That's overall verified access. Then there is transit gateways here as well. Now, Transit Gateway Lab, I would really want to share with you. But there's a difference between Transit Gateway and, so I'm just going to click that. I wanted to show a difference between Transit Gateway and VPC peering. So remember, we have done VPC peering, but there is an interesting article that just explains what Transit Gateway exactly is and what it does not do. So if I go for AWS Transit Gateway versus VPC peering. Okay, so there are some differences between Transit Gateway and VPC peering. This guy has put some interesting comparisons there. What is VPC peering? We already did that, right? So we create one VPC in one region. VPC 1, region 1. VPC 2, region 1. VPC 3, region 2. So suppose this VPC 2 was in region 2, VPC 3 was in region 3. You can make a connection between all three VPCs. In fact, in our lab, we did that. We had two VPCs in two different regions, and then we made those connections. So AWS VPC peering connection is a networking connection between two VPCs that enables you to route traffic between them privately. Instances in either VPC can communicate with each other. So we already did that VPC peering. Advantages of VPC peering are low cost is since you need to pay only for data transfer, no bandwidth limit. Disadvantages are complex at scale. If you have, suppose, 20 VPCs, then VPC peering is what? To let the 2 or 3 VPCs talk to each other. That is called peering, VPC peering, right? So suppose there are 3 or 2, it's okay. Peering is it's good with less amount of VPCs. But when suppose you have 20 VPCs, 30 VPCs here, it's a big company, suppose. So then VPC peering really fails in that it's not really made for complex servers. So complex at scale, each new VPC increases the complexity of the network, harder to maintain route tables compared to transit gateway. So TGW is if you have a bigger amount of VPCs, then you really go for that. No transit routing and maximum 125 peering connections. So you can have 125 peering connections per VPC. You can make a pretty big network of VPCs with the help of transit gateway. If you have 3 or 4 VPCs, and better to go for peering. And also transit gateway will do one more thing. Transit gateway not only connects large number of VPCs, but it also connects on-premises branch to VPCs. So when you have large scale requirement, lots of VPCs, and then you have head office, you have branch office with direct connect. There's a service called direct connect. Direct connect is dedicated service. So AWS direct connect. So it's a lease line, right? So dedicated network connections. When do you use direct connect? So how it works? The AWS direct connect cloud service is the shortest path to your AWS resources. While in transit, your network traffic remains on the AWS global network. So that's the first benefit. If you purchase expensive AWS Direct Connect from your office to the nearest AWS data center, right? So when you send your data in transit, your network traffic remains on AWS global network. You never go to internet where hackers are just waiting for you. So traffic remains on the AWS global network, which is pretty secure and never touches public internet. So that's the first direct connect benefit. Obviously it's expensive. This reduces the chance of hitting bottlenecks. Okay, on the internet there could be huge traffic coming from nowhere and everywhere. So reduces chance of hitting bottlenecks or unexpected increases in latency. So it's just data is arriving late, which you were not expecting, but it can happen. In creating a new connection, you can choose a hosted connection provided by an AWS Direct Connect delivery partner. So you can talk to, suppose your company's internet connection is with Bell, right? So you can talk with Bell and you can ask that, hey, do you have Direct Connect? Are you an AWS Direct Connect partner? Probably Bell, Rogers, those are the big ones here. will have partnership with Azure, Google Cloud, and AWS. So obviously, when you connect, suppose they say yes. So this means that what really happens, suppose they yes. And why are we talking about direct connect? Because it's part of the direct transit gateway communication or discussion. So AWS Direct Connect. There's
So
that same similar service in Azure as well. Yeah.
125, if we have subnets, don't need transit gateway.
So if we have 125 subnets, then we need, it's the opposite statement. Then we really, really need transit gateway.
Oh,
It's opposite.
and if it is like 124 or 120, then
If it is 2 or 3 VPCs, then we don't need transit gateway.
how about a
If
100?
Yeah, if it has 100, 200, 300, then we do need transit gateway. Transit gateway is for large environment. VPC peering is for small environment. So this is the map where it is talking about how transit gateway really works. Just make a better one.
There's a whole, we need a whole page.
Mhm. Yeah, I'll be sharing that whole page as well. So this is when we talk about transit gateway, so you can connect your local branches through, suppose this is Rogers network, and Rogers network, wow, what a bad way to get Rogers. So Rogers Telecom says that yes, we are partners of AWS Direct Connect. Right? This is AWS Direct Connect. So what happens is that they put AWS routers there, because when we say lease line, it's not like they dig out lease line in under the earth and then take your head office or connect your head office to the nearest AWS data center. So they have to connect. They have to connect through routers that are already inside the data centers of Rogers or Bell, right? So this means that Rogers will have AWS devices or routers to which your branch routers will be directly connected to. This means as soon as you leave your branch network, your data is still traveling on AWS equipment, right? That is direct connect. This telecom will have its own infrastructure, and all next hops will be AWS equipment. Your data will be traveling only on AWS equipment. Obviously, you will be paying a lot of stuff, a lot of equipment there, but your data will be traveling on AWS devices to the nearest AWS data center, and that's where. So direct connect, uh, we have that. So then it will hit that transit gateway. The gateway, suppose, is connected to large number of VPCs. So VPC 1, 2, 3, 4 here, 5, 6 here. Maybe it's 50 VPCs, 100 VPCs. So transit gateway is built to connect large network to each other. May it be lots of VPCs with head offices on premises as well. Right?
So, excuse
Yeah.
me, is this a special dedicated line or just a special router?
So transit gateways on the AWS side is receiving large amount of traffic. On the AWS, if there are lots of VPCs, so transit gateways, let them connect to each other. And if you want to connect from head office, that is a dedicated line. If you're using from head office to AWS. What type of connection are you using? Are you using side-to-side VPN from head office or the internet AWS, or are you using from head office a direct connect line to internet AWS? So
So,
if you're using direct connect, it's a dedicated line. If you're using side-to-side VPN, you're using normal internet.
also it is my question is this a physical line or is it just
No.
a special router who connects you,
Yes,
give you the direct connection?
exactly. That's what I was saying here. It's routers and it's AWS devices till the nearest AWS data center. So your data only travels on AWS devices. It's not a dugout line.
It's a
Because
special devices.
yeah, and because obviously maybe our office is on 22nd floor in downtown, so we cannot. And maybe there are 300 offices in downtown. They all want to connect, so we cannot dig out line for all of those. So that's why they say that okay, it's our equipment always that your data will be traveling on, and it's just routers. Okay, but what we need to understand is that you use transit gateway when there's a large number of VPCs, right? That needs to make connection with each other, or maybe there is VPCs plus branches as well, head office, branch office, that all need to connect to the VPCs. So then you really need transit gateway, and there are connections coming from all types of sources, right? Either head office or between VPCs across AWS. So now that is, the purpose. If we talk about purpose of AWS, so that is the AWS Transit Gateway. So that is the purpose when we talk about that. But its lab I saw, and I obviously I can't just start without testing it myself. I was testing it, but there was not a lot of time for me to make sure that it's lab ready. So this will be, I will make it ready by next class. But it's pretty interesting and it's not a very big lab. Although we can make it big. I mean, I'm going to be using 3 VPCs connect. Then if you use 300 VPCs as well, it's pretty much the same procedure, right? So about Transit Gateway, this article really talks in detail because when we compare, it's always good to know then properly that what's the difference between VPC peering and transit gateway. So now we know the difference between VPC peering and transit gateway. Difference between VPC peering, transit gateway. But lab is due. Yeah.
One more thing. Can we end this class today here? And then do, or either we can do on Tuesday lab with
Well,
you.
Tuesday is a problem. All the students here, if they say yes, then yes. It's democracy.
Because we are only two here on day.
So it depends on David. So, you or
That we are 4 or 5 people in the class, right? So if we go together in the class, it's a big lab. Said next lab, transit gateway.
and well, next topics are also Route 53, and then there are other
So
topics
transit gateway and
to
Route 53,
watch.
we can add it together.
To watch
Broad watch.
services. So we have those topics upcoming. So, um, until democracy is reached, I will have to continue. So let's go on. There is transit gateway. Yeah, so there will be a lab coming soon, and we'll be going for transit gateway attachments. We're gonna use all that. Other than that, mirror sessions. You don't have any traffic mirror sessions in this region. Traffic mirror sessions normally we can just. So I will be explaining all that when we are coming back to Transit Gateway because it has something to do with Transit Gateway as well, and large amount of traffic. So the rest of the topics actually connect to the Transit Gateway from one way to another, Cloud WAN and VPC. So I'll be making sure that these topics are ready, especially the Transit Gateway lab is ready. But what we can do here is, yeah,
Mirror is just like a backup mirror.
yeah. So mirror sessions basically is that you can create mirror traffic across the WAN, and that it would be redundant traffic that
Redundant traffic,
can,
right?
yeah.
So redundant
So
traffic, which is a backup. If the one traffic, if one line is busy, then move the other
yeah,
line. Something
but
like that.
yeah. So see this. A traffic mirror session establishes a relationship between a traffic mirror source and a traffic mirror target. A traffic mirror session contains the following resources: a traffic mirror source, a target, a traffic mirror filter. Now, what it contains is this, but the main thing is here. Traffic mirroring is an Amazon VPC feature that you can use to copy network traffic from an elastic network interface type interface. So you want to copy, there is some traffic going on. Suppose there's an email traffic going on from a network card. You want to mirror it or copy that traffic. Why would you want to do that? You can then send the traffic to out-of-band security and monitoring appliances for content inspection, threat monitoring, troubleshooting. So now this is also in VMware. There's a thing called mirroring, and in fact, let me just quickly draw this here. So AWS mirror session is all about this session. Now, suppose you have a virtual machine EC2 instance here that has a lot of traffic, uh, moving from there. So EC2 instance, and that EC2 instance is so suppose there's a network card here, and that network card is releasing a lot of traffic. Now, this traffic, maybe the users are saying that, hey, when there's a traffic inbound, outbound, and inbound, so there are some data dropping there, and I have to send that data again, or so there's some issue with that. Maybe it's taking a lot of bandwidth, or too much data is going out as we're not expecting that much data. But there's too much data going on. So you need to investigate something going on with the bandwidth or data dropping. So if you want to investigate that, you can create an AWS mirror session, which means that instead of putting a monitoring for the actual data that is going on, so you can just put in the path of the actual data that is going on. Monitoring application, it has to go through this monitoring application. It will check that. This might slow down the whole speed of the data because after monitoring, it's just being released. So instead of doing that, why don't we create another stream? It will be an exact copy. So suppose there are 2,000 packets going to the actual destination. So there will be a copy 2,000 packets also created, a copy of all those packets or data, and the actual data is going to its intended destination, but its exact copy is created and sent to a monitoring application to understand that what's going on. There were complaints about this data being dropped or this data creating too much traffic, this instance creating too much traffic. So what exactly is going on here? Right? So you can just create exact copy of whatever is being released here as well. Okay.
So is this monitoring is for a quick for a quick session like take a picture of 200 packets and then release, then an hour take a 200
No, it's exact copy. Suppose a user connected here is sending an email which is 5 MB in size. Maybe there are attachments there as well. That email goes out. There's an exact copy of that email created and sent to the monitoring application as well. So maybe there's a lot of 10,000 files are being shared right now with someone, or one file is being shared, 2 MB file is being shared with someone. So exact 2 MB file copy, whatever is being released from this network card, exact copy is being created and sent to the monitoring application as well. A monitoring application, it's only going to be for diagnostic purposes. The application will try to then through application you will try to check that what kind of problems are happening in the data that is being released or inbound outbound data that is. So exact copy of whatever is going in, whatever is incoming is created, and that copy is sent to the monitoring applications for data inspection and diagnosis. That's the purpose of
they also store this.
Yeah, so that data is stored and then monitored, and when not needed, it's deleted. It's your data now. I mean, you can just keep on saving it somewhere without deleting, or just extract the results what you want and then delete the data, because that's just extra data. So that is mirror session.
So we will do the mirror also in the next lab.
No, there's no lab for that. This is to understand, because then we don't have monitoring applications or subscription to monitoring applications, and what kind of data can we release. So that's gonna then be confusing as well. But we need to understand for this one. Yeah, there are labs for Transit Gateway, Route 53, CloudWatch, databases, they're all labs.
Like if we go to the AWS labs, they don't have predefined labs for us.
Well, AWS doesn't, but A Cloud Guru, if you take a membership, yeah, they have it.
When we are going and try to enable this this feature, so AWS allow you.
Yeah, so AWS, well, you can then practice that there. I didn't practice that, so yeah, it will not be available. I have to search that too. So, but if you want to do it, yeah, go for that and try to do the lab. I don't have a lab for this. I don't think I will have a lab for this. This is monitoring, and monitoring applications have their own complicated way of doing things. We need to understand what it is.
Monitoring is related to security, right? Security, cloud
Yeah,
security.
exactly. Monitoring is for troubleshooting as well.
Mhm.
So yeah, and once so we are talking about this mirror sessions. What are those? And they have created a VPC lattice as well. And this is also newly added service, simplify service to service connectivity, security, and monitoring. Create a service network, create a service, create a target group. So create a service network, name your service network, and set the an auth type to manage client access to the network. Define access and monitoring, associate clients and services. Create associations anytime to facilitate communication within the service network. Resources and associated VPCs can access the services associated with the. So they're just saying that you want to create topology there. Then you can do that. Share the service network for cross-account access using AWS resources. Now, this is obviously interesting because network of services. So this means that suppose you have VPC here, and there is two VPCs suppose created inside. Then there is EC2, that's another service, right? Then there is a user who wants to connect to EC2, so that's a third service. And that user wants to connect to EC2, and that user also wants to save some information in the storage. That's a fourth service now. And there are 100 plus services, right? So this means that you can create a network of services, a logical grouping mechanism to simplify connectivity and apply common policies to a collection of services, right? So collection of services, maybe you want to implement a policy that, hey, whoever connects to this service, VPC, not have the right to delete anything, or to this service, no delete, no delete, no delete. That's just one example here. But you can create a network of services that you are using and put some policies together as well for this network services. So here, if I go for create a network service or service network, so it says here, a service network helps you connect, secure, and monitor services. Clients with settings that you specify. So create a service network, use a name and set an authentication type, service network name, then there is description, then service association. So which service you want to connect here, no VPC lattice services. So you have to give a name first, that what services are there. There was another option there that create a service first. Okay. So how many services you have? Then you come here and connect them as well. So there's a create an Amazon VPC lattice service already showing here. That there is VPC associations. You can associate VPCs to your service network now, anytime after creation. After association, services within the VPC can make calls to services, the service network. Any VPC owner with the access to the service network associate their VPCs to it. Now, you want to connect a VPC to all this, and then do you want to have network access for those services? Do you want to have monitoring for those services? So then you can create that. So choose from your existing Amazon VPC lattice services or create a new one, refresh the list to select it. So suppose I go for create an Amazon VPC lattice service, in case you like lettuce, the vegetable. So you can define access, monitoring, and routing configurations for the lattice service that you create here. You can also associate service to service networks in order to receive traffic from them. So now this is identifier, service name, that's service access. No, that it's better to do it with Transit Gateway, because with Transit Gateway we're going to be using some of the services there as well. So this lab will coincide with the Transit Gateway lab in order to really get a good feel about by doing some one lab here as well. So I'm going to attach it to the Transit Gateway lab, which we will do next week. So we could understand the two topics, VPC lattice and Transit Gateway. So I'm just going to add that to the slide. Okay. So under the VPC, then there is Network Manager here. There's Cloud WAN. If you go for Network Manager, manage and monitor your AWS network. So AWS Network Manager provides tools and features to help you manage and monitor your network on AWS. So Network Manager makes it easier to perform connectivity management, network monitoring, and troubleshooting, IP management, network security, and governance. So pretty much central hub for all the network services that you have. There is Cloud WAN. And then there is Transit Gateway. Again, that Transit Gateway is coming here. Reachability Analyzer. These are all collection of tools under the umbrella of Network Manager. Infrastructure Performance, VPC IP Address Manager. So IPAM, IP Address Manager. This is also a service in Microsoft as well. You just manage IP address. Suppose you have a lot of IP ranges that you're working on. So maybe you want to put it on Excel file. Oh, I have 192.168, 1.0, 192.168, 2.0, 3.0, 4.0. Then I'm using 10.0.0.1 and 10.2.5.0. So whatever ranges you're using, IPAM can offer you the inventory of this in an organized manner. So network access analyzer. So these are the 6 tools that Network Manager has. It also shows connectivity of your global network. Suppose you're connecting from one region to another, and it does show you the global network that are available. Maybe you've created those during, suppose you're connecting from north, so US East 1 to EU West, so European region from US region. So it will just show you then what kind of global networks you have there. So if I click create global network, you're creating a global network in your AWS organization's management account. We recommend that you use delegated administrator accounts to create global networks. It's just saying that, hey, this is your default account. This is the only account you have. So yeah, you don't create it here.
If we use
Create another account.
a cross-region replication, this feature we can use more effectively.
So like it's create a global network to represent your network that includes AWS and on-premises resources. So it just gives you a map of what is connected to what and where. So it's kind of documentation as well, but you can implement some policies there. But no, it does not offer application services or redundancy services. It's just, what is your global network? Let me show you who is connected to what. So
It is
that's the network.
you have to pay for this service.
Oh yes, nothing's free in this world. So name and description and additional settings, but and then create core network and review. So suppose I go for tests and keep moving ahead. So then it says enabling core network will incur additional charges. Yep, definitely it's gonna charge you. Core network general settings, description, core network policy settings. So ASN range, hash locations. Are you using any of those locations there? US West, any of the regions there? How many regions are you using there? Segment name. So if you have created proper networks there, you're using some IP ranges there, and then ASN numbers, autonomous system numbers to connect the two gateways or multiple gateways are created there. Then you come here and add this information. Oh, I have a gateway from North Virginia that connects to Asia Pacific Mumbai or Asia Pacific Osaka, right? So, and from North California to Asia Pacific Tokyo, Canada Central. So when you have created those gateways and they're connected, then you come here and tell the global network. So then global network can show you, okay, you're connected from here to here, here to there, there to there, and there to here. Yeah, if you have that kind of topology, it's going to show you properly there. But there are obviously transit gateway management. So transit gateway still, again, I will be showing that lab. So how to manage everything within transit gateway. Those tools are also available under Network Manager. If you're using any of those features separately, so you put all those features under one umbrella called Network Manager. So if I go to Cloud WAN, if I click the Cloud WAN there, AWS Cloud WAN is managed wide area network. So managed wide area network service. So obviously over the internet when you're connecting, it makes it simpler to build and operate a unified global network. Cloud WAN features a centralized dashboard along with powerful policy management tools with built-in support for network segmentation. So yeah, it just says that AWS Network Manager centrally manages your Cloud WAN core network and your AWS Transit Gateway. Again, if you have added gateways there and connected multiple gateways to each other, so obviously it's over the WAN or on a direct line if you have connected that. So it will show you here. So, okay, the guy is really after me. Mm, okay, so AWS Network Manager centrally manages your Cloud WAN core network and your AWS Transit Gateway network across AWS accounts, regions, and on-premises locations. So different AWS accounts, if you are also connecting, then it shows you the connectivity. It lets you connect that way. So centrally manage your Cloud WAN core network and Transit Gateway network using Network Manager. Again, it comes down to Transit Gateway. Where what I'm planning to do is to create 3 VPCs and then connect them together. Uh, there's a process to create a transit gateway. Once that is created fully, then we can come to AWS Cloud WAN, where you can centrally manage this uh, service, right? Um,
One more question. They were asking about um, AWS core services. The core services are EC2 and Lambda, DynamoDB, or SNS service, something like that. So do we have association with those AWS Cloud WAN?
Cloud WAN is just connecting multiple VPCs, multiple regions or gateways together. So if you have a lot of VPCs created here in suppose North Virginia region, and then through gateway you want to connect to VPCs that are created in Europe region, Frankfurt region. So suppose there are 3 VPCs here and 3 VPCs here, and you want to transfer data between these VPCs. So you create transit gateway. Transit gateway can suppose you have 5 or 6 transit gateways between different regions here. So Cloud WAN will then centrally show that, oh, you have that many transit gateway that are
It provide you big picture in one page, yeah,
for just the networking between
for
the
the networking
regions.
side.
Yeah, only networking side. So DynamoDB is database, and Lambda is just for the code for
Function.
developers that can run on AWS hardware. So there are different things, different
Why they
services.
call them core services? That was my question.
Well, core services are obviously what services are most important to every company, and I would consider these as core services. IAM, EC2, S3, VPC. That's what every company will be using. But yes, there are for developers, the core services will be any service that is offering application development. So depends on who's looking at that and who's considering what. But every company would use, even developers would use all 4 of these. And since there are 100 plus services, though, so they have a list of others as well that are mostly used. Yes, they could be AWS core services. We can just check from AWS documentation as well. If they talk about, otherwise, the question could be, there you go, core services. AWS consists of many cloud services that can use. So core services are core cloud capabilities are those that most applications will require simply to run. And Amazon Web Services offers a broad set of global cloud-based products, including compute, storage, database, analytics, networking, mobile, developer tools, management tools, IoT, security, enterprise applications. These are services.
These are the core services.
Yeah.
So
So,
do we have a session with using AWS Lambda or DynamoDB, database?
well, I can since I'm a Microsoft side of guy, so I'll be showing AWS SQL Server, which is arch rival of DynamoDB. So if you're a database guy, you're a DBA, database administrator, or you have just interest in databases, so any one database you should understand. I'll be showing how to deploy a SQL Server in AWS and connect to it and how tables look like, that much. Otherwise, you should be doing separately a database course, understand then databases.
Okay. We do have a lab about Lambda. We have a lab on Lambda also. We will do this.
I will try to create one small lab for Lambda. I just need a code to throw into into Lambda, and it should execute that code. We should understand the logic. It's for basically programmers and developers. If you're a programmer, you can just come up with the code, put in Lambda, and it will execute that code.
Yeah,
What Lambda
execute
does.
the code. Yeah. Or
So,
from the if you are uploading the S3, from S3 bucket to uh, you know, if you're uploading from S3 bucket, so the
yes.
actually in the background the Lambda function activate.
Yeah, that's what I was saying, that you take out code from S3 or from anywhere else and put it in Lambda. It will then execute it. Yes, so when that topic comes, then obviously we'll talk about that. Um, so we were talking about Cloudvan as well. Again, this is about um, yeah. It was when we create the transit gateway. Seems like everything is connected here with transit gateway. So then we're going to talk about the rest of the topics as well. But right now, what we're talking about, yeah, Cloudvan. So it is also related to the gateway lab, but it's going to show it centrally. Suppose you have multiple transit gateways connected in a big environment, then it's going to show all those centrally here with Cloudvan.
So it
Um,
configure the network policy also automatically. So
no, we have to. Network policy, obviously, always administrators put there. So what they want to deny, they will deny it. What they want to allow, they will allow.
so network policy means a security group, right?
Well, no. Network policy is what you want to allow and not allow, but it has a long list of many other things that are not present in the
Access list.
security group.
Access list also comes into
Access
this.
control is also is about who is allowed, who is not allowed, what port is allowed from where, and what is not allowed. So when I go to Cloudvan, it also just takes me to the same place, which is the global network. So it's all about centrally showing your already big network to give you a big picture of what's connected to what and where. That's what Cloudvan and global network shows us. If I go back here, so again, when I create a transit gateway lab, then we can show all this. Now, um, well, what I was planning to do was that instead of going for these topics, because this is related to one lab that I will still prepare and present next week. So we can visit other topics and finish them as well, like CloudWatch and even databases. And so we could cover some more topics while I'll be finalizing the lab for Transit Gateway. So I will be covering the rest of the topics as well here. So according to that, I'll just then VPC is there. Normally VPC just gets deleted easily, but it says network instances are there. This means that the EC2 instances need to be delete it first. Just put it on delete and let's go ahead with Route Watch, Route 53. We can cover that too. This is going on. If I go to the Route 53 first, okay, so instances are deleted. Good. So if I go to Route 53, Route 53 is a DNS service that lets us lets the name-based traffic connect on a very large scale, and you can do traffic management, availability monitoring, and domain registration. Suppose I go for a dashboard here and then create a hosted zone. Let me explain also what this hosted zone is all about. Suppose you want to connect one. So what are DNS services really used for? Suppose you have some machine here that is hosting a website. So suppose this is the Toronto branch. And here you have web server, which is publishing a website. So there is a company site, and this needs to be accessed by a lot of people. And but it's really hosted on your company's machine. Now, for it to be accessed, you need to have some internet presence. So suppose you put your company website. Suppose it's Bitcoin dot ca. You created a website called Bitcoin.ca, and when all people, anyone writes in the browser Bitcoin.ca, so it should, then you go to the Bitcoin.ca, you go to the DNS manager, you say that you create a record that whoever connects to this website, redirect that user to, suppose this is, suppose this 39.43.234. I'm just going random here. So go to this public IP. And this public IP is actually the IP of a router that is deployed in this branch. So that does not copy, so I'll just go for here. Now this is the IP of the router in this branch, and that router, so branch router, and there's a port forwarding there that if any kind of port 80 or 443 traffic appears here, 80 or 443 traffic, so public is connecting from here, from all over the planet. When they type this, then you want the traffic to go to this IP, and this IP is the IP of the branch router. That branch router has a port forwarding rule that whatever traffic is coming from this domain and its port 443 or 80 traffic, redirect it to this web server. So now when the users reach here, they see a excellent site there with all the categories. Maybe you're selling something here. The thing is, during suppose Black Friday or Boxing Day, in regular throughout the year, maybe you were getting like 10K users, but during Black Friday or Boxing Day, you actually got 500K users. And this really increased huge amount of traffic. which is DNS traffic, or by name, they were trying to access your website that is hosted here by going connected to this domain and then redirected to the actual website that opens in front of the users. But the traffic was huge. So if it was not a very good DNS service, if suppose this domain was hosted, suppose by GoDaddy.com. This is a very famous domain selling registrar, GoDaddy.com. These guys are hosting your domain here. You purchase a domain from them, right? But when there's a huge traffic that hit the domain, their DNS servers were not ready for, suppose their DNS servers, it's a pretty big company, but suppose their DNS servers were not ready enough to, they were not expecting that kind of traffic hitting your domain, and many of the users, or maybe 50K users, were actually disconnected. And when they were trying to open the site actually crashed on at least 50,000 users from the 500,000 users that were connecting. So you lost pretty much 50,000 users. There could have been some users who would have purchased your whatever you were selling there on the website, because of DNS services not able to scale up to the traffic that is coming there. So you lost a lot of business. It could be, suppose 100K users instead of 50K actually were disconnected because the DNS servers could not take that kind of bandwidth or that kind of traffic. They could not offer that kind of bandwidth. So that's where then AWS and Azure and Google Cloud, they all offer corporate level scalable DNS service. So Google Cloud Platform, GCP, they all offer this service. So AWS offers Route 53, which is port 53 is the DNS port, right? So Route 53 is a service that offers DNS traffic. Azure offers DNS, its name is DNS, that's it. And GCP also offers some kind of DNS service. I forgot the name for that, but it also offers DNS service. So Route 53 says that, hey, you bring it on. You bring on whatever level of traffic you want. We can really take up whatever you bring to us. So we are scalable, and we can scale up to even 500K or 1000K even if you bring. So we will be able to scale that, and you will not lose a single user. That's what AWS, Azure say. Obviously, they will charge you for that, but they can scale. That's what they really boast about. And they can increase the bandwidth to whatever amount of users that hit your DNS name there. If I go back here and I say that I'm in, this is Route 53 dashboard, and I want to do traffic management, DNS management, availability monitoring, domain registration. So you want to purchase a domain, you can purchase domain directly from AWS as well, instead of going to GoDaddy.com. They sell domains as well, as low as 0.99. In fact, the new class that we started, Microsoft 365 services, Exchange, Teams, Intune, and SharePoint. So we will be purchasing actually one domain, $1 worth of domain as well. And we're going to purchase from there. AWS is also a domain registrar. You can purchase domain from here. Then the good thing is that when you're using AWS services, suppose you want to use the Route 53 of AWS, so why don't you then purchase the website from AWS as well? So that's the idea, that then you don't have to really redirect traffic from GoDaddy, and GoDaddy might not have that kind of infrastructure that AWS has. So purchase a website there. They will host your domain as well as route the huge traffic that you're expecting. Suppose you are expecting wherever you want it to go. So if we go for create hosted zone here, so if I click that and then go for so this is the name of the domain that you want your traffic. So suppose it's Bitcoin armor.ca, and this is all about cryptocurrency, suppose, and public hosted zone. So it is we're expecting traffic, huge traffic from public. So first you say that, okay, I want to create a zone for this. So you create a zone, you define the domain name here. It creates a name server that, okay, these are the name servers in UK and across the planet, wherever .net.org. So when the traffic hits, we have a lot of DNS servers here that can take your traffic. But then you say that, oh yeah, I want to create a record, or I want to create maybe any other record. So if I go for create a record and I want to suppose you want to redirect the traffic to your branch, right? So you can go for web. You can create a record called web.bitcoinarmor.ca. So somebody goes for a web or site maybe site.bitcoinarmor.ca. So suppose you say when you advertise this, if you type this address in your browser site.bitcoinarmor.com, so then you will go to our Bitcoin site. That's what you advertise, right? In the background, what you do, you want to create an A record, you want to create AAA, which is IPv6, CNAME record routes traffic to another domain name, or MX, which is mail servers. Suppose there's an email going on, TXT, PTR, pointer record, service traffic, center platform, I think it's that SPF, not recommended. So there are many types of traffic that you can redirect. But suppose you want to redirect traffic to certain IP. Suppose I put some IP here. Why not I just put my IP? Right now my IP is, okay, what is my IP? Right now my ISP has given me this public IP, but it will change very soon. All residential IPs change soon. So suppose I put there some kind of IP. So whenever the traffic hits site.bitcoinarmor.ca, redirect that traffic to this public IP. Suppose this is the IP of your branch, this one, right? That IP, but suppose the other IP, my IP was there. So when somebody hit that site.bitcoinarmor.ca and whatever IP I put there, it will just simply redirect to that IP. And it time to live TTL 300 seconds. For 300 seconds, keep on trying. If we can connect, we can connect or not. So I'm going to click create record. And now it says that, okay, so whoever goes to site.bitcoinarmor.ca should be redirected to this public IP. I haven't configured this. This is my DSL router public IP, public side of the IP, right? Internet side of the IP. So if I go to my DSL router and create a port forwarding and say that, hey, whoever connects from this side, the traffic comes in with this port, redirect redirect from here from my DSL router to my that machine in my house. Right? So we can
Excuse me.
all that. Yeah.
So if the traffic is over like more than 300,000 clients, it will go to redirect to site.bitcom.
Like even if traffic is 500,000, it depends on what is the capacity, what is the bandwidth available with AWS, because it's going to hit AWS DNS servers. We know that AWS has huge data centers across the planet. So we don't know what is the maximum limit of the DNS, how much bandwidth it can take, how much connections it can take maximum. But it says that you just bring it on. Although it has to be dug out in the documentation that what is the limit.
So you enable bitcom army.ca. This is the Route 53. You bought this bitcom?
No, suppose we buy it. I just went for some random name here.
I mean, you buy it
Yes.
from AWS for Route
Yes.
53, right?
Yeah.
So why we
we
need a
purchase it from AWS.
site.bitcom? Once we have a bitcom, why we
Yeah.
need a site.bitcom?
Like it does say that, hey, suppose it's an email, right? So you will add here mail.bitcoinarmor.ca. If it is an email traffic. So if it is a web traffic, you can just put here web.bitcoin. So you have to create some kind of subdomain which will give the purpose, what kind of traffic you're expecting. So it is just for much more organization
So
that you can put here.
so Route 53 will manage like email goes to the
Yes.
different traffic and
Well, we are telling it what to do, right? So if it is site.bitcoin.ca, so go to this public IP. Suppose I create another record here, and that says that mail dot bitcoin dot and this is MX traffic, so it's email traffic now. So that will say that okay, what is the fully qualified domain name of your email server, right? So we have to write that. Suppose it's Exchange Online. So I'll go for priority one, and suppose its mail server is mail365.microsoft.com. Suppose that's their Exchange server address. We have to check it out. So it will send whatever traffic is connecting to mail.bitcoinarmor.ca will be forwarded to our online exchange server anywhere. So this subdomain, or actually this is a record name, is just for organization that one company will have different types of traffic coming there, not just one type. If it's different type, then give it a name. You could organize it and tell that where this type of traffic go, where this type of traffic go, where this type of traffic go, where this type. You can separate it as well. That's why you can have to add an actual record name here.
so when you hit create, it gives you the new IP address.
No, I put an IP address here, right? So suppose I have that branch IP, so I will put it there. So if you don't put any IP, no, it's not going to put itself anything. So then it will not know that if the traffic hits here, where should it forward it to if we don't put this area.
Okay.
So it will not know. So this is how then, but AWS just says that, hey, there's a test record here, right? I selected this and this is my actual IP now. So if I click test record, and I say that, hey, why don't you test it? Settings to simulate DNS queries optional. There's a get response here. Click get response. It says no error. So it actually was able to ping to me. It's green, and my IP actually exists. So it simply tested it and it says that this is the IP, and there is no error to that. So this means that it's a legit IP, and it was able to get right now. It's gonna change really soon, so that's why I put it there. So yes, traffic test can be done as well there. And one more thing, edit record. If I go, so the routing policy. There's another thing called routing policy here, and there is weighted. There's geolocation. There's latency. There is failover. There is multi-value answer. And then there is IP based. So that is actually the specialty of coming here to Route 53, because you can implement any kind of policy here. So what are those policies? What do they really mean? Basically, they mean redundancy, that whatever size your traffic is, we're going to try to not lose any traffic, right? So routing policies let you choose how Route 53 routes traffic to your resources. If you have multiple resources that perform the same operation, such as serve content for a website, choose a routing policy other than simple. Here's a brief comparison. So it's a simple routing policy there that, yeah, your traffic comes, we're gonna let it go. That's it. Oh, you want something else? Like weighted records let you specify what portion of traffic to send to each resource. What is a weighted record? Weighted record is that you create actually two records here. Site one Bitcoin .ca and give one IP. Normally, a branch, suppose your company opens a new branch and requests an internet connection. So normally, a company or commercial entity gets multiple static IPs. This is my residential IP, right? So residences get one IP, one public IP. And it keeps on changing. It's not static. Companies get multiple static IPs by default from the ISP. So you can create site1.bitcoinhounder.ca with this IP. Maybe you got another IP. Maybe you got 5 IPs there. So site2.bitcoin.ca and another IP you got from your ISP. So you can put it here, and then weighted just means that you can. So if I go there, if it's weighted, so you can go for site1 dot the domain name .com and site2 dot domain name .com. So what will happen is, if there's a huge traffic coming here, it's overwhelming, so it's going to redirect some of the traffic here as well. It's going to divide the traffic among the two, or it will do round robin, which means first whoever requests first come here, whoever requests second come here, third here, fourth here, fifth here, sixth here, seventh here, eighth here, and so on. So weighted just means that it's going to just decide that if you create 2 records to the same resource, both redirecting to the same resource. But now, one record does not have to take all the traffic. It's divided between multiple records here. Right? So DNS will, Route 53 of AWS will offer this redundancy for DNS traffic. There is geolocation. So geolocation records let you route traffic to your resources based on the geographic location of your users. So this is very good. This user, suppose there's a user here connecting from Europe region, and there's a user connecting from US region. So your services are in Europe and in another region, in EU as well. So this Route 53 offers the same services in EU region as well as in US. So suppose you created a copy of that, or you made a replication of this. So exact replica of this is in EU as well. So now a guy from EU actually tries to connect to the US copy of the .ca. So geolocation service will check, oh, you're coming from EU, so you should be connecting to our its exact replica site that we put there, and that is your current site. So why connect here and open the site quickly instead of connecting there, and then it's going to be comparatively slower. Geolocation services just check that if there's a replica created, which replica is near to that user, and redirects the user to the nearest, Route 53 location to connect to the site and open the site. That's geolocation. And latency records let you route traffic to resources in the AWS region that provides the lowest latency, which means very fast. All resources must be in AWS region. So it just simply says that, okay, the traffic is coming there through this record. Traffic is also coming through this record. But there's too much, suppose there's already too much traffic in this A record. So it sees that, oh, there is much lesser traffic in this record. So it will just simply decide that where there is low latency, where there is high speed, and less chances of being late. So it just automatically decides one of the 2 records which has lesser traffic and routes the new traffic to that. So it could go faster. So it just simply is intelligent to define the route to take that is faster. So that's what low latency is all about. Then there is IP-based. So IP-based records let you route traffic to resources based on their IP addresses that you know. Okay. So that's also, suppose you prefer that there is this IP and maybe there is another IP. and that is 189. I'm just going random here as well. 543, 89. So you prefer, for some reason, that uh, first, whatever traffic comes, it should hit this IP always. If this IP gets overwhelmed, maybe there's traffic. Maybe there are 50,000 plus connections. Whenever it breaches or it goes more than 50,000 connections, then redirect to this IP as well. So you have some preferences for IP addresses. You can choose that too. Failover, as the name says, failover records let you route traffic to a resource when the resource is healthy, or to a different resource when the first resource is unhealthy. It's also simple that if there are two records here and somehow the traffic is going too slow with this record, so it's gonna simply fail over to the other one. So other one will not be used at all. It will be active passive combination here. Or passive just means standby as well. So if active is down, so the passive or standby will become the new active, and all the traffic will redirect from here. So that means the service has failed over. It's no longer, first one is no longer taking any traffic. Second one is not taking all the traffic. You can fail over to the other record as well. And multi-value answer. Multi-value answer records let you configure Route 53 to return multiple values such as IP addresses for your web servers in response to DNS queries. So multi-value is that there are much more traffic connected, DNS traffic connected here. So why don't I just route it to this branch IP? Remember that all branches get 5, 6, or 10 IPs, and you can request even more. They're all static. So suppose there is multiple services on the internet. So there's DNS service. There is mail service. Mail service you're offering, and then there is web service you're offering. So whichever service requests are coming more. Suppose there's thousands of users who want to connect to your website. So you say that, okay, I have another IP. Why don't you connect all the web traffic to the third public IP that I have? But if there are emails coming for me, then why don't you just connect it to the first IP that I have? So you can have multi-value answer. You can choose which IP to receive. And then in the router, you say that if traffic comes to this IP, send it to web server. If it comes to this traffic comes to this IP, then send it to the other server that I have. So you can also decide that what type of traffic. Exactly. Yeah.
Can we have
So
a break for 10
yeah.
minutes?
Okay. Well, yeah, I was done anyway. Okay, so let's take a break. I'll just put that here. Okay, so we talked about Route 53, and that is also done. And so I'll just go ahead and delete then there are traffic policies here that if you have created certain uh, records, then it um, can show you that which service exactly you're connected to and how much traffic is going on to that service. So this is just showing that. And policy records are also if you have created an elastic load balancer, if you've created a S3 storage, so how much traffic is going to all those services. So that's showing here. The registered domains, you can purchase domains and it's going to show here all the registered domains. And also pending requests. So if there are any pending requests, we redesign bring domain. Yeah. So any domain request that you've purchased a domain in $20 per year, so it's gonna show you all the pending requests that are there. Endpoints, inbound endpoints is just Route 53 is over. So if you have inbound traffic coming from your network to a VPC, and it's huge traffic, so then you can use Route 53 to really regulate the name-based traffic. Region US 1, region US West 1, they both offer if it's coming from your network or it's coming from the website, suppose gyo.example.com to your VPC. So in both cases, it can resolve that traffic, and obviously you can make the traffic redundant. You have to configure endpoints. You have to tell the Route 53 that, hey, I'm expecting on this VPC and that VPC a lot of Route 53 traffic or DNS traffic. Please regulate that DNS traffic. So that's for resolver for inbound and endpoints. And then there are DNS firewall rule groups. So there's one rule group already created there. It's not associated to any VPC, but it already created when I created a resolver, and this is just through a firewall, the DNS traffic can go. And whatever firewall policies you have implemented in the firewall, suppose you have implemented the firewall, then it's going to also check and protect or cross-check the DNS traffic. Well, so that's how the whole Route 53 is. If you have any kind of name-based traffic going to and from internet to your VPC and the branch, then you can use the Route 53 service or DNS service to really regulate all the traffic and make it highly available. So guys, we're gonna try to we're gonna just finish it till here, and we're gonna connect next week with the transit gateway service and cloud WAN and whatever network topics remaining. Then we're gonna also go for database services and CloudWatch, because those are a bit longer topics and we won't be able to cover by the end of the last time. So we'll just cover till these topics, and well, see you next week then. Have a nice weekend.